Hello, Aurora lovers. This is Dalebone from Dalebone Imaging, and this is Aurora Hunting 101. This is blah, blah, blah. This is episode 37. What is the Space Weather Prediction Center's Enthusiast Dashboard? NOAA produces a lot of useful information. Unfortunately, it's not organized. The Enthusiast Dashboard has a collection of Aurora and solar information. Let's take a look. The group within NOAA that deals with space weather, including auroras, is the Space Weather Prediction Center, SWPC. And that's where all the forecasts come from, the 3-day forecast, the 27-day forecast, the Aurora Oval. And all of those pieces are on different web pages, and they're sort of scattered around, and you have to dig to find them. Often you can just search for them with Google or some other search engine, but they're sort of simplistic collection of space weather information is on the Enthusiast Dashboard. They do have some other dashboards, but this is what I look at. So it's Space Weather Enthusiast Dashboard from the SWPC. And this is what it looks like. It's got current conditions. So R2 is if there's been a solar flare, that's the amount of solar X-rays, solar proton flux, and the geomagnetic activity. And this is just summary. So we generally care about the geomagnetic activity. That's where the KP values come from. And this R value is whether there's been a very strong solar flare on the sun, which, we all hope will generate a lovely aurora for us, and it will if there's an associated CME that is Earth directed. And you can see the time graph of the flares that are an indication. Well, these are the X-ray measurements from the solar flares. You can see there was a spike today. There was a very big one yesterday. That's one of the biggest ones in more than a decade, apparently. So there's one area in the sun that's very active right now, and it's generating these big flares, and hopefully CMEs associated with that. From the Aurora perspective, that's interesting, but no one needs to do the analysis of the imagery to see if there's a CME that's associated with that is Earth directed. That big one, they're still trying to decide. Probably. And those will show up in this over here, which is the 3-day forecast. And this is what your apps show. They take this text and convert it into a nice graph and convert these UTC times into your local times. And that's pretty much what all the apps do for the 3-day forecast. They're all showing the same data. This spike here for 5.3 and 4.67, basic 5 plus and 5 minus, GU1 in terms of geomagnetic scale is coming from this. Plus there's a coronal hole that's contributing as well. So, there's quite a range from 2 up into 5. And if you read into the descriptions, there's descriptions underneath here that you don't get to see in apps that tell you a little bit more about it. They're saying that it could be up to G2 instead of G1, which would be KP6. But apps filter out that information. So if you go to the actual NOAA sites and learn how to interpret these often dense blocks of text, you can get a little bit more information. Whether that helps you or not, it's hard to say. The trending graph for KP values, we got to KP4 yesterday. Again, these are in UTC time, so you need to adjust. If you are in Central Standard Time, that's 6 hours off of UTC. So your day starts here. Oops. Or midnight starts here, sorry. So this would be 6 p.m., 9 p.m., midnight. If you're Eastern Standard Time or Mountain Time, it'd be, a hour difference one way or the other, depending on which one you're in. Let's get some pictures. The ultraviolet, you can see if there's a coronal hole. So this little coronal hole there is possibly enhancing the aurora. We had sort of an unexpected display of aurora 2 nights ago. Was that 2 nights ago? Yes, 2 nights ago. And it lasted all night, and that was probably caused by the stream out of a coronal hole. Visible light, so you can see the sunspots. The ones that are over here, the ones that are causing the flares. You can see flares. Actually, probably is in there if you click on this. Click on it, it expands. Again, this doesn't really have anything. See, that's you can see that eruption going off there. Oof. So that's coronal mass ejections coming off the sun. And these little flashes in there, those are actually high energy particles hitting the detector and causing a flash in them. Every once in a while, Venus or probably Mercury shows up in some of these pictures, and people want to know what that is. They've got the solar wind information. So out of that, we would be interested in BZ primarily. So when it is negative, that is good for aurora, especially if it's negative for quite a while. And then the other one is BT. So that's the total magnetic field of the solar wind, and BZ is the north-south component relative to the Earth. And when that's negative, it allows the particles from the solar wind to flow more easily into the Earth's magnetic field or get captured, or however you want to express it. I don't care about phi. I don't know why they always note it, but for aurora purposes, we pretty much ignore it. Density is important, so how many particles, 10 or higher is always good. Speed, if the solar wind is faster, it tends to have a bigger impact on the Earth's magnetic field, which is always good. Temperature, I don't know too much about how temperature impacts the aurora, so I mainly ignore it. Looks like they lost data there for a while. There's gaps in the data. Oh, you got to click on it to hide it. We'll come back to that one. So this is the Aurora model. So it'll keep updating. And you can play it and you can see the predictions over time. So this has got a lead time currently of 51 minutes. That changes based on the speed of the solar wind. That's the time it takes for the wind to get from the satellite to Earth. You can see it was 70 minutes and then it went to 55. I think they lost data in there. But you can see at HPI of around 50, the oval extends down close to the US border. So depending on where you are, if you're down in Toronto or some of these northern states, you need an HPI of 60, 70, 80, maybe even up into 100, depending on how far south you are. But you can see how, as the HPI changes, how that oval expands and shrinks. That, I've said that many times, that is what I pay attention to at night. I don't care about the KP, because for a given KP, this can vary significantly. You can have KP4 and a positive BZ, and the oval will shrink, and you probably won't be able to see anything where I live. Or it can be 2, and The HPI can be 60, 70, and we'll have a wonderful display. And you can look at it and scroll back and forth. The time that is down here, it's in UTC, of course. Everything NOAA does is in UTC. So when they ran the model based on the satellite data, and this L1 would be the Discover satellite out at the L1 Lagrange point when that measurement was taken. So, and up here is when that forecast is for. Usually it's that 77 minutes out or whatever that gap is. So I always say look at that oval at night. And it gives you about an hour lead time, which is always good. Proton fluxes, that's going up just like it is in this one. So mainly what's streaming off the sun is hydrogen atoms, because that's what the sun is mostly made out of. So those atoms get ripped apart in the sun and split into just the protons and the electrons, and they flow out separately as plasma. And so this is a measurement of the number of protons that are flowing out. You got electron flux, so also measuring electrons. You can see that went up a little bit there. And magnetometers, that's where our Kp values come. Well, let's see. Well, that's certainly not. That's not where the Kp comes from, because Kp is from the Earth. But that's measurements of the magnetic field. Estimated Kp. They say estimated because it takes a long time for them to actually calculate the actual official Kp value. And this estimated Kp is real time, but it's close enough. You can see this is radio blackouts. We don't really care about that. So when there's a big flare, it knocks out radio or affects radio communications for large parts of the planet. So right now, this is night side, so it didn't get impacted, but daylight here had an impact. This we don't really care about. So getting back to this, most apps don't have this because it's so sort of complicated and we don't really need to know about it. So what this is the NOAA model of the solar wind coming out from the sun. And it's got, the top one is density, so how dense, how many particles are in there, and the bottom is velocity, so how fast is it flowing. So the center, the round yellow dot is the sun, and then there's these 3 dots over here. The green one is Earth in the middle, and the red one is the stereo A satellite, and the blue one is the stereo B satellite. Apparently, I haven't confirmed that, but the A and B might actually be from ahead and behind, because when they were launched in opposite directions. One's going clockwise around the sun, the one's going counterclockwise. And they've actually gone all the way around, or almost all the way around. And they're back near Earth, which means we don't get a particularly different view from them than other Earth-based satellites, which is unfortunate, but they're still moving. I think stereo A is dead, that it's not communicating anymore, but this is a model, so it's not actually data from the satellite. So I think they still have that in the model. So when there's flares, or CMEs, sorry, not flares, if there's CMEs, you get this burst of material that flows out and ends up essentially in a spiral pattern. You get sort of this pinwheel. If I animate it, you can see as the sun rotates. So there's a big CME. So you can see, woof, all that material that got blasted out. So it looks like something's going to hit Earth based on this model. So that's that. You can see this spike here in terms of density there. So that's a lot of material. So that's going to be late on the 16th is the estimate. And then, of course, there's going to be an increase in speed. Now, it looks like there was actually 2 events in there. Like there's an initial one, and then there was, looks like another high speed one coming behind. I don't know if that's 2 parts or there was 2 flares that happened. You can see basically almost overlaid here. So this one is looking top down. This is looking from the side because it's happening in 3-dimensional space, right? So there's a band north-south effectively from our perspective, and east-west, right? It's showing both orientations there. It looks like some pretty dense material is going to hit us. Like I said, density of 10 is, or higher is good. This is, close to 60, 50, 60. And interesting, you can see that they're predicting that Earth is going to get hit by it. Stereo A is going to get hit by maybe even more. And then stereo B, which isn't that far away, is going to get less, much less. Which might be why NOAA doesn't want to say anything quite yet about what the impact on Earth is going to be. And then the speed, when those happen, they actually do compress the solar wind in different ways. So sometimes you get multiple pulses here. So it's fun to play with. It gives you an idea of looking at this. If you can try and figure out if we're going to get hit by a lot of material, and it'll give you an approximate time. So again, UTC time. So this would be 17 would be midnight. So this is going to be 6 hours earlier. So midnight UTC is 6 p.m. So this is going to probably hit in the afternoon where I live. It looks like there's something coming after that too, maybe. So yeah, velocity. So the material tends to be more dense, and then the speed of it changes, right? Yeah. So these ones are just sort of slow, normal flows, and then that comes flying out at a much higher speed, right? You can see it traveling across and, starting to somewhat disrupt this arm, right? And affecting this one. It's a dense material's got a magnetic field. It does, it's basically eaten part of this stream as it goes by. There isn't really anything behind this CME. Not really important for just wanting to go out and see the northern lights. You can just like NOAA is going to take all this into account when they make their predictions as best they can. But I find it interesting to look at, and it's a somewhat confusing graph or display. So it's nice to be able to understand how this works, right? This is top down, so looking down from above, and this is looking at the side. So this is north south. This is from Earth. This is east and west of us, approximately relative to the sun, right? And then this is a graph based on the density of that material or the speed of the material coming out. NOAA, I believe NOAA also does one of these, and they do their own calculations, and sometimes they differ. Yeah, this is mainly for radio interference, so we don't care about that. Same with this, other than it's got that KP values. With that satellite KP values, What we really care about is this one here and the forecast. So there is some interesting information on here, but this is why I usually say just get an app instead of starting with this. I think it's useful, but I think they could have, if they really wanted it to be useful, they could reformat some of this and allow you to put in your location and adjust the times to your location, things like that. But no, they just, like, I get this email to me and it looks exactly like this. So they're just putting that block of text up on the web page. So that's the NOAA Space Weather Prediction Center Enthusiast Dashboard. It's got some information related to Aurora. It's got the 30-minute forecast and the 3-day forecast. And it's got some interesting but not necessarily that helpful information in terms of the model of the solar wind and, when there's, it's got the X-ray values, so we know when there's a solar flare and hopefully associated CMEs. But I don't think any app that displayed the information in that way would survive very long. There's almost every app is displaying the same information in a better, easier to understand format. So that's why I recommend most people use that. Some of the more experienced people still rely on the Enthusiast Dashboard. I think Space Weather Live is a better alternative to that. But I'm not aware of any app that has that solar wind model in it. So that's always interesting to look at. You can just get directly to that just by Googling the label that's at the top of that. But poke around a little bit and see if there's something interesting in there. They do have explanations for some of those, each of those blocks. So going and reading the help in there and the details might improve your understanding of the aurora and solar weather in general. With that, please check out episode 37. What is the Space Weather Prediction Center's subscription service? I think you probably might have an idea already, but I'll do that as the next episode. And I'm wishing you clear skies and happy hunting.